Hi students, in this video I'll be going through the 2023 A Math Paper 1 question 12. Right, so this is a question related to quadratic equations, and it requires you to do completing the square, right? So let's read the question. So a ball is thrown vertically upwards, so its height h meters above the ground at time t seconds after being thrown is given by the formula h equals to 1.75 plus 5t minus 5t squared. So as you can see, it's a quadratic equation. The highest degree of t is 2. Okay, state the height above the ground from which the ball is thrown. Okay, so this ball is not being thrown from the ground. So let's say you have the ground over here. Okay, so this is the ground. So the ball may be thrown from somewhere here. Okay, then it goes up to the maximum point, and then it comes down. So the maximum point is somewhere around here, right? So they want you to state, so they want you to state, right, what is this height? Okay, the initial height, okay, from which the ball is, the initial height from the ground from which the ball is thrown, right? Okay, so actually, if the question asks you state, right, you can actually, you should be able to tell what is the answer without doing any working. Okay, but in case some of you are wondering how do we get the answer? Okay, look here. So state the height above the ground from which the ball is thrown. So at the start of the particular scenario, right, the ball will be thrown. Okay, so what we can say is that when the ball is being thrown, okay, do you agree with me that we can consider the timing to be 0? Okay, basically it's the initial height of the ball, okay, because the timing only starts when the ball is being thrown. All right, so actually to get the answer, okay, what you can do is you can write when t is equals to 0, okay, then you compute out h. But why the question says use the word state, because you should be able to compute this without doing any working. Okay, because you can see that if we were to put t equals 0 inside the equation, right, okay, then it becomes quite obvious that the two terms behind these two terms become 0, okay, leaving us with only 1.75, right? Okay, so the height from which the ball is being thrown will be 1.75, so this would be the answer. Okay, right, so I hope so far you're able to understand this part. Okay, so express, okay, part B, express h in the form of a plus b times t plus c square, where a, b, and c are constants to be determined. Okay, so they want you to determine what is a, b, and c lah. Okay, so whenever the question asks you to express a quadratic in this form, right, you should be familiar that what you need to do is to do completing the square, right? Okay, so let's try to do completing the square for the original formula. So h is equals to 1.75 plus 5t minus 5t squared. Okay, so to make this more familiar to you, I think I will rearrange this formula first. So I'll put it the t squared term in front, then the t term in the center, and then the t to the power 0 term or the constant term at the back. Okay, so to do completing the square, the first thing we need to do is to factorize out the coefficient of t squared, right? So because we can only do completing the square when the coefficient of t squared or x squared is 1, right? So factorize out. Okay, so then you ask yourself one question, negative 5 times what will give you 5t, right? So it should be quite obvious that it's negative t, right? Negative 5 times negative t gives you positive 5t. So you must always get back what you have in the original equation. Then you ask yourself, negative 5 times what will give you 1.75. So it should be obvious that it's something negative also. But how to get the answer? Just take 1.75 divided by negative 5. Okay, then you will be able to get negative 0.35. Okay, so when you expand back, you should be able to get back what you have originally. Okay, so this is a good way to check whether you have done the factorizing correctly or not, right? Okay, so now we can do completing the square for the term that's inside the brackets. Okay, so we have t squared minus t. Okay, so remember to do completing the square, we will add the square of half of the coefficient of t. So the coefficient of t is now negative 1. So we add -12 square, right? And because we have added it in, we have changed the value of the expression. We need to subtract away, okay, so that it is still equal, okay, to the previous line. Okay, so we look at this. Okay, so these three terms, okay, we will complete the square, so it becomes t minus half square, right? So if you expand this t minus half square, you should get back this, and this term, right? Okay, then you just combine this whole term using your calculator. Okay, you should get -3/5. Okay, then we will just multiply the -5 back. Okay, so you will get +3. Okay, then we will rearrange in the form that they want us to do so. So 3 minus 5 t minus half square. Okay, so if you were to do some comparison, then it will be obvious that A is 3, okay, B is -5, and then C will be -half. Okay, so this will be the answer for part B. Right, so not too difficult. Okay. Okay, the steps seem long because I show every single step. Okay, but in normal practice, if you are familiar with it, you should be able to skip a couple of steps, right? Okay, the next part, hence state the maximum height attained by the ball and the time at which this occurs. Okay, so if you were to plot out the graph, so I've used decimals to plot it out, but of course in exam, you can't use decimals, but you should be able to know how to draw the quadratic graph, okay? Okay, from the completing the square form. Okay, so over here will be 1.75, as you can see. Okay, so remember the answer we got from part 1, the ball was thrown from a height of 1.75. Okay, so ignore the part of the graph that is before time 0. Okay, so the ball goes up to the maximum point, okay, and then it comes down. Okay, then it reaches the ground here. Okay, so also ignore the part up below the ground. Okay, hence state the maximum height attained by the ball and the time at which it occurs. So the maximum height will be here. So they want us to state what is the maximum height, and then what is the timing that it occurs. Okay. Okay, so of course, we can't use decimals to plot out a graph and then use a graph to tell us what is the value of the maximum height and the time. Okay, but we will be able to tell from the equation in the completed the square form. Okay, so the answer that we got for part B is this, right? Okay, so the way to analyze this thing is you observe this square term. Okay, so a square term, as we know, no matter what value of t we put inside, right, this square term, is going to be either equals to 0 or bigger than 0. So t minus half whole thing square is either greater or equals to 0. It will be equals to 0 if t is equals to half. Then half minus half square, you get 0. If any other value of t you put in, minus half, you square it, is going to become positive. All right. Okay, so now in front here we have 5, but even if you have a 5, it doesn't matter. Okay, 5 times something positive or something 0 is still going to be greater or equals to 0. Okay, so you think about this, the whole expression is this. The whole expression is like this. Okay, the whole expression is 3 minus, okay, maybe I'll talk about -5. So if I have a -5, if I put a negative in front of the 5, right, negative times something that is either greater or equal to 0. Remember, if you multiply by negative for inequality, then you got to reverse the sign. All right. Okay, then now we're going to add in the 3. So if I add in a 3 here, then I need to add in a 3 here. Okay, so in fact, what I'll get is this. Will be less than or equals to 3. Okay, so essentially it tells us that for this particular expression, which is actually h, right, it will be less than or equals to 3. So it's either equal to 3 or less than 3. In other words, do you agree with me? Okay, less than or equals to 3 means the maximum is 3. Okay, because you are either equal to 3 or less than 3. All right, so that will be the maximum height. So maximum height will be 3. Okay, and the time at which it occurs. When will this expression, when will this whole expression be equals to this one? When will this whole expression be equals to 3? Okay, will only be equal to 3 if I have 3 minus 0, right? Because 3 minus 0 will give me 3. Okay, so in other words, I need to make this whole thing 0. Okay, and when will this thing be 0? The only value of t that will make this whole thing 0 is t equals to half, right? Because half minus half will give me 0. 0 square 0. 0 times 5, then it becomes 0. Okay, so the time at which it occurs would be at t equals to half second. Okay, okay, so you can see that the graph that we have plotted using Desmos agrees with us. Okay, as you can see from the scale here, okay, over here is 2, over here is 4, so this is right in the middle, so this is 3. Okay, and this is time 0, this is time 1, this is right in the middle, so it's time equals to half. Okay, so the graph that we plotted using Desmos agrees with us. Okay, but this is the way to think about the maximum or the minimum value, okay, of a quadratic function when it's in the completed the square form. All right. Okay, let's move on to the next two parts of the question. So this is a rather long question for quadratic question on quadratic equations or quadratic functions. Okay, the ball eventually hits the ground. So we know that the ball hits the ground here, right? Okay. To explain why the time taken for the ball to hit the ground is not twice the time found in part C. Okay, so this one, if you are well versed in the drawing of the graph, so you should be well versed in the drawing of the graph, because when you are able to draw, you can tell actually rather obviously, right? Okay, what is the answer for this particular question? So you see, for the first half second, the ball traveled from 1.75 to the maximum point, right? So because this is a quadratic graph, there's a symmetry to it. Okay, in fact, this t equals to half is the line of symmetry. So the next half second, the ball will actually travel from the maximum point until here. Okay, where it goes back to 1.75. So over here, you can see it's 1 already. Okay, then to reach the ground, it will be after 1 already. Understand? Okay, so the reason why the time taken for it to hit the ground is not twice the time found in part C is because the ball was not thrown from the ground. Okay, that's why the time it takes to reach the maximum height and the time it takes to from the maximum height reach back the ground will not be the same. Okay, in fact, it will definitely be more than double. Okay, so how are we going to write this in words? Okay, so I'll write something like this: the ball is not thrown from the ground, so the time it takes to reach the ground from the maximum height will be more than half a second. So what I'm saying is that the time it takes the ball to go from here to here will be more than half second. All right. So we conclude, hence the time taken to hit the ground will be more than twice the time in C. All right. So it will be more than twice. So it will not be twice. All right. Right. Let's go on and do the last part of the question. Okay. So find the length of time for which the ball is at least 2 meters above the ground. Okay. So I'm going to erase away some of the markings here. Okay. So you can use this graph. Okay. So when you throw the ball from 1.75 up and then it comes down, there will be a period of time where it's more than 2 meters above the ground. So when is it more than 2 meters above the ground? It will be here. Okay, this period of time. Okay. Okay, so basically they want us to find this length of time from here, this timing, let's call it T1 until here. Okay, T2. So basically what they want us to find is the T2 minus T1. Okay, so we've got to find these two timings first, then we will just take the difference. Okay, so how do we find these timings T1 and T2? Okay, so you see, this is the line h equals to 2, right? Okay, then so basically these 2 points T1 and T2 are the intersection points between h equals to 2 and the equation of the graph, okay, the function, okay, the quadratic function. So to find intersection points, what we'll do is we'll solve simultaneous equation. Okay, so what we can do is we can write when h equals to 2. Okay, so when h equals 2, we find the two values of t. All right. Okay, so something like solving simultaneous equation. Okay, so this will be equals to 2. Okay, so we'll bring the 3 to the left side. So sorry, the right side. So we'll get this. Okay, 2 minus 3 will be -1. We'll divide both sides by -5. So we will get 1/5. Okay, then what we'll do is we'll square root both sides. Okay, so remember when you square root, you will get two answers, plus minus square root of 1/5. Alright, so t will be equals to half minus square root of 1/5. So this will be the smaller timing, or t will be equals to half plus square root of 1/5. Right? So this one will get 0.05279 seconds. Okay, then from here I'll get 0.9472 seconds. Right, so we'll calculate the length of time. Okay, so we'll take the bigger timing, okay, minus the smaller timing. Okay, so we'll get 0.894, okay, to 366. Right, so this duration of time over here, okay, from here to here will be the 0.894 seconds. So that's the duration whereby the ball is at least 2 meters above the ground, 2 meters or higher. Right? Okay, so a rather long question for a quadratic function question. Right, but not too difficult. Right?